So let's try to go for some more problem on hydrogen atom. Now let's try to go for this one. This is one of the very interesting problem. Suppose we have a ground state wave function, and the radial part of ground state wave function is R10, and this is 2 by a naught to the power 3 by 2 e to the power minus r upon a naught. So this is our radial part of wave function, and r is between 0 to infinity. And now what we have to do, we have to calculate the average value of p square. And we also want to calculate average value of p4. So then what will happen? What will be average value of p square? So obviously people can approach in a direct way also. So in general way, how you will approach it? In general way, you will approach this particular problem as that average value of p square is basically, you will just go for integration 0 to infinity, and you have radial wave function, that is r1 star, and basically you will just go for p square and r10 r square dr. And what is p square? Is the momentum. And fortunately, you are very fortunate here that your momentum is only translational. This momentum is this p square. We have to write this particular p square in term of operators. So how we will write this particular p square? This is very interesting. So what is p square here? Can anybody suggest me?
So it is the square of that operator.
What operator? What operator? That is the thing. Suppose you have to calculate the value of expectation value of p square. How you will approach? So this is very interesting. Now look at here. So if you have kinetic energy operator, then kinetic energy operator is basically p square by 2m plus you have, this is translation kinetic energy, so pr square upon 2m, and there is rotational kinetic energy p theta square, or some you can just go for L square upon 2m r square. So this is your complete kinetic energy. But you are very fortunate that we are asking for the ground state. So this L is equal to 0. So there is not any significance of this particular thing, isn't it? Why? Because L square. So this is basically p square upon 2m plus this is basically L into L plus 1 h cut square upon 2m r square. So obviously for the ground state, L is equal to 0. So basically my translation kinetic energy is basically p square upon 2m. And for the ground state, my Hamiltonian is just like p square upon 2m plus potential energy, and that potential energy is E square minus E square by 4 pi epsilon naught you have, and this is for the ground state. But if L is equal to not 0, then obviously this thing will come into picture. Now what is this p square here? This p square is basically radial kinetic energy, and this is calculated at minus h cut square upon 2m, and you have d square upon dr square plus 2 by r d upon dr. Are you getting my point? So what is your p square here? So you can just cancel this 2m, then your p square or pr square is nothing but minus h cut square, that is d square upon dr square plus 2 by r d upon dr. And this is my momentum for the this is my momentum square for the ground state for this particular ground state. है ना? So if you will put it here, p square, and then you have to differentiate it twice here, and you will have to just do all this calculation, then it will take a lot of time, isn't it?
Yes, sir.
हाँ है ना? और अगर p4 में चले जाओ, suppose I just want to calculate what will be p to the power 4, then it will be havoc in the examination. Are people going to understand this thing?
Yes, sir.
So how we will approach this type of problem? And you will see this type of thing will come into atomic physics also when you will go for relativistic correction and all kind of thing. Relativistic correction of hydrogen atom and all this thing will be discussed by Mukaddar sir. And then you have to see that there p to the power 4 is very important thing when you will go for the relativistic correction. So how we will approach it? So now look at the approach of this particular problem. Okay. So if we will approach this particular problem in a different way. So how we will approach it? So let's first go for expectation value of p square. So what we want, we have my Hamiltonian, and this Hamiltonian is p square upon 2m plus, and this is your total kinetic energy. Don't worry, this is your total kinetic energy, p square. You can take rotational kinetic energy and translation kinetic energy, total kinetic energy plus potential energy VR. And now, what is your p square? The p square operator can be written as 2m Hamiltonian operator minus potential energy operator. Are you getting my point? So this is your p square operator. And now, if we want to calculate the p square operator, the expectation value of p square onto this particular thing, and I can write this value is just 10 or R10. So what will be this? So this value is 2m. We have R10, H R10 minus potential energy. You have R10 potential energy R10. Now, what is this particular value? इसकी वैल्यू कितनी हो जाएगी?
minus 13.6.
So this value is 2m, and that is minus, I can write E1, है ना? लिख सकते हैं ना? So
Yes, sir.
you can write E1 is the ground state energy. So that will be minus 13.6. And what is this particular value?
Sir, some constant into average value of 1 by r.
Yes, so some constant. So what is this particular constant? So you have this particular thing is R10, and what is VR? Minus E square upon 4 pi epsilon naught 1 upon R, and you have R10, isn't it? And when you are going to calculate this particular thing, and you can write this thing in term of E square and 4 pi epsilon naught also. So what will be this value? 2m. And what is E1? बताइए क्या होगा? You know what is the expression of En? What is expression of En? En is equal to minus m upon 2h cut square E square upon 4 pi epsilon naught whole square into 1 by n square, है ना? Isn't it? And what is n? For the ground state, n is equal to 1. So this value is basically, so you can write this particular value. E1 is minus m upon 2h cut square and E square upon 4 pi epsilon naught whole square. So this is your first one. And what about this one? So this minus this thing will be what? Plus. And you will take E square upon 4 pi epsilon naught common, and you have to calculate expectation value of 1 by R. Isn't it?
Yes, sir.
And what is expectation value of 1 by R?
1 by A naught.
1 by A naught. We have calculated this thing into our last class. So 2m 2h cut square, that is E square 4 pi epsilon naught whole square plus E square 4 pi epsilon naught 1 upon A naught. Now we will put the value of A naught and we can get the answer. हो जाएगा ना?
Yes, sir.
Are you getting my point? So you can easily calculate what is the expectation value of P square in term of bore radius or in term of whatever the notation it is given into your, and you can easily put the value of A naught. So you can put value of A naught is, what is value of A naught? 4 pi h cut square upon m E square. So when you will put value of A naught, you will see the dimension will be exactly same. Clear है ये?
Yes, sir.
So it is very beautiful trick कि आप यहाँ पर क्या कर रहे हो, चीजों को डिफरेंट वे में लेकर के जा रहे हो. बिकॉज अगर आप पी स्क्वायर को करने के लिए जाओगे देन इट विल टेक लॉट ऑफ टाइम, बहुत ही ज्यादा समय लेगा. नाउ लेट्स गो फॉर p टू द पावर 4. सो नाउ व्हाट इज माय p स्क्वायर ऑपरेटर? यहाँ तक क्लियर है ना? You can just put it here and that dimensionally the thing will be exactly same.
सर
बोलो.
सर जो A naught का वैल्यू है क्या उसमें कोई एप्सिलॉन नॉट भी आएगा क्या? मैं थोड़ा सा कंफ्यूज था क्योंकि इसमें एप्सिलॉन नॉट का स्क्वायर आ रहा है ना फर्स्ट वाली टर्म में.
तो आई थिंक एप्सिलॉन नॉट मस्ट बी देयर, होना
Yes,
चाहिए,
sir.
है ना? सो यस, एप्सिलॉन नॉट h कट 4 पाई एप्सिलॉन नॉट h कट स्क्वायर, सॉरी 4 पाई एप्सिलॉन नॉट, सॉरी ऑब्वियसली एप्सिलॉन नॉट h कट स्क्वायर. गुड, थैंक यू. सो दिस इज योर बोर रेडियस. तो बोर रेडियस की भी वैल्यू आपको पता होनी चाहिए. सो 4 पाई एप्सिलॉन नॉट h कट स्क्वायर, यू विल पुट इट हियर एंड यू कैन गेट द आंसर. देखो दोनों का सेम डायमेंशन मिल रहा है. नीचे
Yes,
4
sir.
पाई एप्सिलॉन नॉट होल स्क्वायर, ऊपर चला जाएगा e स्क्वायर, m विल बी देयर. सो एग्जैक्टली वी हैव सेम डायमेंशन, है ना?
Yes, sir.
ओके, चलो. सो लेट्स ट्राई टू गो फॉर द एवरेज वैल्यू ऑफ p टू द पावर 4. उसको देखते हैं. सो अब बताओ p टू द पावर 4 के लिए कैसे काम करेंगे हम लोग? सो अगेन वी हैव p स्क्वायर. सो व्हाट इज p स्क्वायर? दैट इज 2m h minus vr. Okay, so what will be my p to the power 4? So, and please mind it, this is operator, so you have to write it very carefully. So this will be, so this operator can be written as what? P square into p square, and then you can write this particular thing as 2m whole square, because this is number, and we have h minus vr into h minus vr. Okay, so what is this particular value? 2m, and this is what? H square minus h vr minus vr h plus vr square, isn't it? And we have to calculate the expectation value of this one. So what will be now? When we will go for the expectation value of p to the power 4, then how we will calculate? We will calculate 2m, the expectation value of h square minus expectation value of h, expectation value of vr. We can easily write because h will commute to vr, so there is not any problem. And similarly, we have expectation value of vr, expectation value of h, plus we have expectation value of vr whole square. Okay, so what is the expectation value of h square? And this 2m will be always there. So what is the expectation value of h square?
Sir, E1 square.
E1 square, because we are just talking about this thing, so I am writing in term of E1. Okay, that is E1 square. What is expectation value of H?
So 2m square say
2m square. Don't worry. 2m square. Okay, 2m square. Good. Now, what is expectation value of H? E1. What is expectation value of VR? Minus E square upon 4 pi epsilon naught by 1 upon R का expectation value, isn't it?
Yes, sir.
Okay. यहां भी क्या हो जाएगा? You have minus E square upon 4 pi epsilon naught 1 upon R का expectation value. Okay. And expectation value of H is E1. Plus यहां पर जाओगे तो क्या हो जाएगा? E square 4 pi epsilon naught और यहां किसकी हो जाएगा expectation value? 1 upon R square, isn't it?
Yes, sir.
ये मत कर देना, इसका लेकर के स्क्वायर मत कर देना, 1 स्क्वायर का मत कर देना यहां पर, है ना? बिकॉज दिस इज एक्सपेक्टेशन वैल्यू.
सर
हाँ बताइए.
VR square का
VR स्क्वायर का एक्सपेक्टेशन वैल्यू, बिल्कुल.
सो
Are you
देन
getting?
दिस टर्म का भी स्क्वायर होएगा ना?
किसका?
5 sin नॉट.
इसका भी स्क्वायर होगा, बिल्कुल इसका भी स्क्वायर होगा, इसका भी स्क्वायर होगा. ओके. नाउ वी नो व्हाट इज एक्सपेक्टेशन वैल्यू 1 by R. That is 1 upon A naught. Okay. And we have to also calculate the expectation value of 1 upon R square. So what is expectation value of 1 by R square? इसको निकाल लें. What is this value? यहां कर लेते हैं. So 1 by R square. The expectation value of 1 by R square. How we will calculate 1 by R square? You will go from 0 to infinity. And you have 2 upon, that is 4 upon A naught cube e to the power minus 2R upon A naught R square by 1 upon R square dr. This R square is cancel out. What you will get? You will get 4 upon A naught cube into A naught by 2 का पावर क्या आ जाएगा?
Sir, 2 upon E naught square.
सॉरी, ठीक तो है?
सर सही है सर, सही है सर.
सही
2
है.
upon E naught square.
ओके ओके. सो इसका पावर क्या आएगा?
2.
1 ना?
1 ही आएगा तो
1 आएगा. R to the power 0. So this is 1 and factorial 0. So कितना आ जाएगा? 2 upon A naught square. Okay. So expectation value of 1 by R square you can calculate, that is what? 2 upon A naught square. ये आप गलती से मत कर देना कि वहां 1 by A naught square कर दो. Are you getting my point? Because these are operators. So आपको इस तरह से लेना पड़ेगा. Now you can put the value of A naught. And what is value of A naught again? The value of A naught is 4 pi epsilon naught h cut square upon me square. You can put it there and you will get exactly same dimension. हो जाएगा ना?
Yes, sir.
Okay. So just you can finally put and then you can get the answer. ठीक है? So इस तरह के क्वेश्चन अब आप अपने एग्जाम में एक्सपेक्ट कर सकते हो. कहीं भी p स्क्वायर हो, p to the power 4 हो, then it is better than go for Hamiltonian and potential. उन दोनों का कॉम्बिनेशन बनाइए p स्क्वायर के टर्म में. और गेटिंग माय पॉइंट, है ना?
Yes, sir.
है ना? तो इसको आप इजिली कर सकते हो. ओके. सो लेट्स ट्राई टू गो फॉर सम मोर प्रॉब्लम. चलो. So let's go for this one. So the state psi is given by 1 by root 6 pi 310 plus root 4 by 6 pi 210 or 211 and plus root 1 by 6 pi 100. Okay, so this is the story. And what is phi NLM? Phi NLM is the energy eigenstate of hydrogen atom. So this is what energy eigenstate of hydrogen atom. So what do you have to do? First question is, if E naught is ground state energy, find the average value of energy. Second question, if E naught is ionization energy, then find the average value of energy. Third, find the average value of L square. Fourth, find the average value of LZ. Find the average value of LZ. Okay, so we have to calculate all this thing. Now, in both this question, you have to find the average value of energy. So the numerical value must be same, isn't it?
Yes, sir.
है ना? लेकिन एक बार आपको ग्राउंड स्टेट एनर्जी के टर्म में देना है सारा आंसर, और दूसरी बार आपको किसके टर्म में देना है? फर्स्ट एक्साइटेड स्टेट की एनर्जी. सॉरी, then you have to write it in term of ionization energy. So you have to be very careful. Okay, so first is very trivial. So if you are just want to, and you can see this is normalized state, 1 by 6 plus 4 by 6 plus 1 by 6 is 1. So this is normalized state. Now let us try to, so if Hamiltonian will measure on a state psi, what will be measurement here?
E naught by 3 square.
E naught by 9. Very good. So probability of E naught by 9 is equal to what? 1 by 6. And from the second question, what will be measurement from this one?
E naught by 4.
E naught by 4. Very good. So E naught by 4 and probability is 4 by 6. Okay. And third one is E naught, isn't it? And that is again 1 by 6. So obviously the average value of energy, H, is given by 1 by 6 into E naught by 9 plus 4 by 6 into E naught by 4 plus E naught into 1 by 6. Isn't it? So we can take common. क्या common ले सकते हैं? E naught by 6, and that value is 1 upon 9 and 1 upon 4 plus 1. What is this value? This value is E naught by 6, and this is 36. 4 plus 9 plus 36. So what is that? E naught into 49 by 36. यही आ रहा है ना? जरा देख लो, मैं कैलकुलेशन तो मेरी कहीं गड़बड़ नहीं है।
सर 6 भी आएगा ना साथ में?
सर डिनोमिनेटर में 6 भी है सर।
Into 6. Okay. So into 6 also. Okay. So this is your average value of energy. Very good. E naught by 6 is also there. So this is your average value of energy. Very trivial, very simple, straightforward problem. But I am interested into second one. What will be answer of second one? The average value of energy must be same. So what will be answer of second one? First one, we have given the answer for first one. And you can easily calculate 49 by 36 into 6. So I am not interested into that part. But for this one, I get answer E naught into 49 by 6 into 36. Okay? Isn't it? This is very interesting, na? E naught 7 square by 6 cube. Wow. एग्जाम में ऐसा दिया रहेगा क्या? ओके, सेकंड का आंसर क्या होगा बताइए?
सेकंड है
एवरेज वैल्यू ऑफ E1 निकालेंगे।
क्या क्या निकालेंगे?
E1
E1 क्या निकालोगे भाई? आपको किसके टर्म में आंसर देना है? यहां पर E नॉट क्या है ये जरा बताओ।
ग्राउंड स्टेट एनर्जी।
ग्राउंड स्टेट एनर्जी वो कितनी होती है?
दैट इज 13
तो आप यहां पर एक तरह से लिख रहे हो -13.6 इंटू 7 स्क्वायर बाई 6 क्यूब, यही है ना? यस। और यहां पर आपको एवरेज वैल्यू ऑफ एनर्जी किसके टर्म में निकालनी है?
आयनाइजेशन एनर्जी।
आयनाइजेशन एनर्जी। सो व्हाट इज आयनाइजेशन एनर्जी?
The answer will be plus 13.6 into 7 square is 6 cube.
तब तो दोनों का आंसर अलग हो जाए, एवरेज वैल्यू ऑफ एनर्जी तो सेम ही रहेगी। इफ यू आर सेइंग योर आंसर विल बी प्लस 13.6 तो बहुत बड़ा ब्लंडर हो गया ना। एवरेज वैल्यू ऑफ एनर्जी ऑन दिस स्टेट विल बी ऑलवेज रिमेन सेम। एक बार में प्लस 13.6 आएगा, एक बार में माइनस 13.6 आएगा, ऐसा कैसे होगा?
Yes, sir.
सो व्हाट विल बी आंसर? आपको ई नॉट के टर्म में आंसर देना, यहां तो मैंने समझाने के लिए दिया हुआ है। यू हैव टू गिव द आंसर इन टर्म ऑफ ई नॉट। हियर ई नॉट इज ग्राउंड स्टेट, डोंट वरी। हियर ई नॉट इज ग्राउंड स्टेट and here E naught is ionization energy, E ionization. Okay, what will, but answer must be same, don't worry. What will be answer, Puneet?
सर जो E नॉट एनर्जी है वो हम लोग देते हैं तो उसकी वैल्यू पॉजिटिव होती है, बट आवर आंसर शुड बी नेगेटिव, सो एक माइनस साइन दिया जाएगा फाइनल रिजल्ट में।
Obviously, आप जब बात कर रहे हो आपको किसके टर्म में लिखना है? अब देखो, इसको क्वेश्चन को कुछ इस तरह से समझने की कोशिश करो। अगर आपको इस प्रॉब्लम को करना होगा तो आप कैसे लिखोगे? लेट अस गो फॉर दिस वन। अगर मैं फर्स्ट प्रॉब्लम करूंगा देन आई हैव टू राइट 1/6 इंटू E3 प्लस 4/6 इंटू E2 प्लस क्या हो जाएगा ये 1/6 इंटू E1। ओके, एंड व्हाट इज E3? E naught by 9, E naught by 4 and E naught. E2 is E naught by 4. And what is E2? Sorry, what is E naught? Is minus 13.6. Are you getting my point? यहां पर E naught की वैल्यू क्या है? minus 13.6. But here I have the, if E naught is ionization energy, then what will be ground state energy?
माइनस E नॉट।
Minus E naught. Are you getting my point? If E naught is ionization energy, यहां तो आप एनर्जी ही मेजर कर रहे हो ना, तो एनर्जी मेजर कर रहे हो लेकिन आप रिप्रेजेंट करना चाह रहे हो किसके टर्म में? आयनाइजेशन एनर्जी के टर्म में। So what is the relationship between ground state energy and ionization energy?
Eg equals to
Minus sign.
naught.
The relationship is all about minus sign. So what will be answer here? यहां पर क्या हो जाएगा बताइए. So अगर आप एवरेज वैल्यू लिखोगे, so average value of H is 1/6 into E3 and E3 will be in term of ionization energy क्या होगा?
minus E naught by 9.
Minus E naught by 9, exactly. So that is minus E naught by 9 plus 4/6 into minus E naught by 4 into 1/6 into minus E naught. So for the second question, what will be answer? For the second question, answer is minus E naught into 49/6 into 36. और यहां ई नॉट की वैल्यू हमने क्या पुट किया था? -13.6. और यहां पर ई नॉट की वैल्यू क्या पुट करोगे? +13.6. So that will be minus into +13.6 into 7 square by 6 cube. So you will get the exactly same answer. Are you getting my point? भाई आप निकाल तो एनर्जी ही रहे हो ना. You are finding the average value of energy, but you want to represent it in term of ionization energy. So what you are doing? So first excited state को आपने किसके टर्म में लिखा? आयनाइजेशन एनर्जी के टर्म में लिखा. बट एनर्जी के टर्म में लिखोगे तो that value should be negative. So here the answer will be minus E naught into 49/6 into 36. Are you people comfortable now? ये एक बार TFR में क्वेश्चन पूछा हुआ था.
सर
हाँ बताइए.
सर जब माइनस ई नॉट टेकन दैट इज ओके, बट सर एंड में हमने ई नॉट वाई वी हैव टेकन दैट 13.6.
क्योंकि आयनाइजेशन एनर्जी तो 13.6 ही होगा भाई.
ओके, हियर ई नॉट इज आयनाइजेशन. ओके.
Are you getting my point? आयनाइजेशन यहां पर इसकी वैल्यू बताओ क्या है? What is this value?
-13.6.
इसकी वैल्यू क्या है?
Here if that is ionization energy 13.6.
13.6. तो इसकी वैल्यू तो 13.6 ही पुट करेंगे ना. लेकिन
Okay.
हमें निकालना क्या है? एवरेज वैल्यू ऑफ एनर्जी. तो एवरेज
Yes.
वैल्यू ऑफ एनर्जी विल बी नेगेटिव ऑफ आयनाइजेशन एनर्जी. आर यू गेटिंग माय पॉइंट?
Yes.
गुड. सो इसको एक बार ध्यान से कीजिएगा. ओके. सो दिस इज वंडरफुल प्रॉब्लम. बहुत ही कंफ्यूज कर देगा आपको एग्जाम में, है ना. सो ऑलवेज ट्राई टू यूज द करेक्ट नोटेशन. चलो. So next we are going for average value of L square. Okay. So if you are going for this, what will be average value of L? So what will be measurement for L square? 2h cut square, है ना. So L square. So probability of 2h cut square is, इसको मेजर करेंगे 2h cut square, इसे भी मेजर करेंगे तो 2h cut square, और इसे मेजर करोगे तो 0h cut square. So what will happen? So probability of 2h cut square is 1/6 plus 4/6, because इन दोनों से आपको क्या मिल रहा है? 2h cut square. इससे भी मिल रहा है और इससे भी मिल रहा है. So that value is equal to what? Sorry, 4/6, 5/6. And last one is 0h cut square. So 0h cut square के लिए क्या मिल रहा है? 1/6. Okay. So what will be average value of L square? The average value of L square is equal to 5/6 into 2h cut square plus 1/6 into 0h cut square. So what is that value? 10/6h cut square, है ना. Now जब आप LZ के बारे में बात करोगे, LZ के बारे में अगर इसे मेजर करोगे क्या मिलेगा? 0h कट. इसे मेजर करोगे 1h कट. इसे मेजर करोगे 0h कट. So probability of 0h cut is what? 1/6 plus 1/6. That is what? 2/6. And probability of 1h cut is equal to 4/6. So average value of So your average value of LZ is 0 h cat into 2 by 6 plus 1 h cat into 4 by 6. So that will be 4 by 6 h cat. Okay. So this is also a nice question. एग्जाम में इस तरह से क्वेश्चंस आते हैं. ठीक है. Okay. Now let's go for this problem. This is very interesting. The state psi is given as 1 by 4 pi 1 0 0 plus 4 by 6 pi 2 1 1 plus 1 by root 6 pi 3 1 minus 1. Okay. Where phi NLM is the energy eigenstate of Hamiltonian. Now my question is, what is the expectation value of Lx? Very interesting. What is the expectation value of Lx? How you will approach?
Sir, we can make those L plus and L minus matrices.
Very good. So आप इसको L plus और L minus करोगे. But before going to do L plus and L minus, let us try to see this particular state very carefully. You can see every state has different value of n, isn't it?
Yes, sir.
So if you will operate L plus here, it will not go to 1 0 plus 1 तो जा ही नहीं सकता है, so that will be 0. Okay. But if you will go for this one, it will also, ये L plus पर जाएगा तो कहां जाएगा? 2 1 1. So that will be also 0. Okay. ये कहां चला जाएगा? If I am operating L plus here, where it will go?
सर ये L से 0 पे चला जाएगा, 310
0 पे चला जाएगा. But you have not any combination that is 310, isn't it?
Yes, sir.
So आप यहां देख रहे हो, if this n is different, L और M कहीं भी जाए, they will be 100% orthogonal to other state, isn't it?
Yes, sir.
है ना? ये तभी सरवाइव करेगा जब n की वैल्यू सब में सेम होती तो, या फिर किसी दो में सेम होता. Then it will survive. But here I am just taking the value of n is different. अगर कुछ ऐसा रहता 200 या फिर 300, then this, and then it is also not going to survive, because you have to just check first. You have to same n and same L होगा तभी survive कर पाएगा. Otherwise they are 100% 0, isn't it?
Yes, sir.
है ना? Because what is orthogonal relation? The orthogonal relation is n L M pi n dash L dash M dash. This is your orthogonal relation, that is n dash L dash M dash. So this is your orthogonal relationship. So for using L plus and L minus, you have to make sure that will be not 0 if your n is equal to same and L is equal to same. Only those terms will be survive, otherwise all term will be going to be 0. Isn't it? भाई L plus और L minus क्या करता है? Only LZ को ही तो, M वाले पार्ट को ही तो चेंज करता है. It is just changing. If you are operating L plus, then M will go for M to M plus 1. But your N and L will remain same. If you are operating L minus, then it will go to M to M minus 1. And N and M should be same. But here you can see, here all N are different. So there is not any need to calculate, to do any calculation, and that part will be 0. Are you people comfortable?
Yes sir.
है ना? So बिना कुछ कैलकुलेट किए हमने सीधा सीधा देखा कि L N की वैल्यू डिफरेंट है, सारा खेल खत्म. अगर N की वैल्यू भी सेम रहती, देन वी हैव टू सी द वैल्यू ऑफ L. तो उसमें कौन कौन सा टर्म सर्वाइव करता है जिसके L सेम होते. आर यू गेटिंग माय पॉइंट?
यस सर.
एंड देन यू हैव टू गो फॉर द M. तो पहले तो आप N की वैल्यू देख लो, L की वैल्यू देख लो, एंड देन यू कैन वर्क फॉर ऑल दिस थिंग. Okay, so in the examination you have to be very much conscious about the indexing you are putting here. Okay, so I think these type of questions you have to work very nicely, है ना? चलो, एक क्वेश्चन आपके एग्जाम में आया हुआ था. Find the expectation value of Z square minus R square in the ground state. What will be that? फटाफट बताओ.
Sir, Z square will be equal to A square.
Z square minus R square. So what is Z square? A naught square minus what is R square?
3A naught square.
3A naught square. So that value is minus 2A naught square. So you can see this type of question will come into examination. So we have almost done different type of problems. So इसके अलावा जो questions होंगे that will come into your atomic physics. ठीक है? So that will come into atomic physics. वहां पर आप सारी चीजों को एक्स्ट्रा देखने की कोशिश करोगे. And we will also do some more problem of this thing when we will go for perturbation. Okay? So this is hydrogen atom from my side. कुछ पूछना है तो पूछ सकते हो.